Okay, so let's get into triangles, little bit of regular hexagons and irregular polygons. So first of all, when we're talking about triangles, okay, triangles are um, they can be what we call equilateral. They can be what we call isosceles. They can be what we call right. Um, I'm gonna put some marks on here to make sure. Okay, so this first one is what we call an equilateral. Okay, and this first part means equal. Okay, and if you recall from when we talked about polygons and quadrilaterals, lateral means side. So this is equal sides. This one is isosceles. Isosceles triangles have two equal sides, these two legs, and also these base angles are equal. So when I think of isosceles, a colleague of mine years ago had a neat little phrase. I saw, let me make that better. I saw two sleeves. So, kind of a little rhyme for isosceles. I saw two sleeves because when we think about sleeves, they're usually equal length. Okay. And this last one is a right triangle. Okay. It is a right triangle because of this right angle here. And we are going to be using some properties of right triangles. So, the first thing that we're going to get into as far as properties of right triangles is something called the Pythagorean theorem. Okay, and the Pythagorean theorem tells us a lot of times we just see it written as a squared plus b squared is equal to c squared. Okay, now a couple of things with the Pythagorean theorem. Okay, it only works with right triangles. Okay, and kind of another way of thinking about it is no, let's not call it side. Let's So I feel like the letters A, B, and C, they're just kind of arbitrary. They are variables. And what do they mean? Well, it technically means the leg squared plus the other leg squared is equal to the hypotenuse squared. Okay. So when we're thinking about the Pythagorean theorem, okay, remember we're dealing with a right triangle. Okay. And these two, this side over here is a leg. This is a leg. And this longest side is the hypotenuse. Okay. So when we are thinking about a squared plus b squared equals c squared, that is literally leg squared plus leg squared equals hypotenuse squared. Okay. So let's take a look at, actually, I'm going to slide this over here. Okay, and let's take a look at an example. All right, so we have this triangle. And we see this little square in here, so we know that it's a right triangle. Okay. And we are told that yeah, we are told that this leg is 3 units. This leg is 4 units. And we're looking for that one. Okay. Well, remember, leg squared plus leg squared is equal to hypotenuse squared. Okay. When we put this in our calculator, we get that this is 9 plus 16, 25. So that is what c squared, or that's what the hypotenuse squared. But you have to keep in mind, the length of the hypotenuse is just the variable. So in order to cancel out the squared, we have to do square root to both sides, which gives us the hypotenuse is 5. Okay. So now I'd like to consider the area of a triangle. Okay. But before we get into that, let's take a little trip down memory lane here. And let's think about the area of a quadrilateral. Okay. And let's say that this quadrilateral is 4 and 6. Okay. So the area of our quadrilateral, if you recall, is just length or base times height. So pretty easy, right? We remember that. Well, if you consider the area of a triangle, and how do we actually make a triangle? Well, if I were to draw this diagonal through here, look at what I've just created. Okay. So I've got this up here, and I've got this here. And if you notice, both of those pieces are equal. So the area of a triangle is 1/2 the area of a rectangle. Okay? So if we have any triangle, and I'm going to draw a triangle like this, okay? You need to keep in mind that this is the length of the base, and the height this is the height. Okay. So the line drawn from the highest point on the triangle to the base, and it must be perpendicular because, like here in our rectangle, these are right angles. That's kind of what makes a rectangle. Okay. So, for example, let's say that we have this triangle here. Um, let's say that's 10. It's going to be 10.6. It's going to be 13. Well, what we have here, we have a scalene triangle. We really didn't go into that, but that's okay. You don't need to know that. Just a little fact there. And we've got a bunch of sides, but really no height because none of these are right angles. However, if we are given this piece here, and this is called an altitude, and we are told that this is 8, now we can say, okay, our area is 1/2 times the base times the height. And the height is that, we call it an altitude, but it goes from the topmost point to the base, forms that right angle. When we throw that into our calculator, we get an area of 52 square units. Now, you do need to remember, area is measured in square units. Okay. All right. Now, the next thing that I would like to talk about is the area of a particular triangle, and this is going to be the area of an equilateral triangle. Okay, so we have our triangle here. And we are going to say that our triangle, each side measures 3 feet. Okay. So in order to find the area, we use the formula. I'm going to say S for side squared times the square root of 3 divided by 4. Or another way that we can look at this is 0.433 times side squared. So for our example here, we would have 0.433 times 3 feet squared, which gives us 0.433 times 9 feet squared. And when we multiply this out, we get that the area is approximately 3.9 feet squared. And that is the formula that you will use for all of your equilateral triangles. Okay. Now, the last thing that I want to discuss in this video is the area of irregular polygons. And when we're talking about the area of irregular polygons, we have to be willing to split things up. Okay. So, for example, let's say that we have this right here. Okay. And we are told that this is 12 feet. This is 14 feet. This is 9 feet. And this is 8 feet. Okay. Well, we can take this and kind of split it up really however we want to. I personally think that it makes the most sense to just kind of split this up right here, because then we have 12 feet by 14 feet here. Okay, because we have our base and our height. And because this is 9 feet, we now know that this little piece here has to be 3 feet. Because this entire length here is the same as this 12 feet up here, which means that this piece in here is 8 feet by 3 feet. Well, now we have two different areas. And so we take the first area, 12 feet by 14 feet, and we add that to the second area. Okay? So when we multiply this, we get 168 square feet, and we get 24 square feet. And when we add that together, we get a total area of 192 square feet. So I hope this video was helpful. Please remember to reach out with any questions. We are here to help.